Hi students, today we are going to learn about Stokes Theorem. Okay, Stokes Theorem, it's one of the important theorems in the vector integration. What exactly is Stokes Theorem states? It gives the relation between the line and the surface integrals. Okay, so this is the statement of the Stokes Theorem. Okay, if S be an open surface, bounded by a closed curve C, and cap left bar is equal to f1i cap plus f2j cap plus f3k cap be any vector point function having continuous first order partial derivatives, then so this is the formula. So that is the integral over the closed curve. This circle indicates the curve is a closed one. F bar dot dr bar is equal to double integral over the S surface curl F bar dot n cap ds. Curl F bar dot n cap ds. As you know, S here, S be an open surface means we can consider something like this, some surface, and this is the C, the boundary, the closed curve, and this is the surface we can consider as a surface. S be an open surface, and bounded by a closed curve C. Like this is the example we can consider. Now where n cap is a unit normal vector at any point of S. Where n cap we can consider at any point on this S. The n cap is a unit normal vector, that is we can take like in this upward direction as n cap. Where n cap is a unit normal vector at any point of S, drawn in the sense in which a right-handed screw would advance when rotated in the sense of description of C. So here that depends on the orientation or the direction of C depends on the n cap, that is unit normal vector. If you take the n cap in the upward direction, and in the upward direction like this, then the orientation, the direction of the C we have to consider in a anti-clockwise direction, like in this form, like in this direction. When we consider the unit normal vector n cap in the upward direction. So there is another orientation we have. If that depends on n cap, if we take n cap the downward direction like this, the downward direction like this, then we have to consider this orientation of C in a clockwise direction, like in this. In the clockwise direction, we can go with the simple example, just like if you take a water bottle or any bottle, if you consider a one water bottle or any another bottles, if you want to open the cap of the bottle, in which direction we actually move the cap? We move in the anti-clockwise direction. To open the cap. To close the cap, we'll move in clockwise direction. So that is where we can take one simple example to remember the orientation of C. So that is what it is given as and the right-handed screw also. The screw, when you try to open the screw, we'll try to use the screwdriver to open the screw, and we'll try to rotate that in a anti-clockwise direction. Again, to fit into that, we'll try to rotate it in clockwise direction. So that's what the example, that depends on the n cap, that is unit normal vector. We'll consider the orientation, the direction of the C, that is the boundary of surface, open surface. That is the boundary of the open surface. Here this is the statement, the important statement. This is the main formula we have. You can see the relation between the line and the surface integral. Now from the surface integral we already know that here these are the important points here. Note 1, double integral over the S curl F bar dot n cap ds can be written, that depends on the projection of the surface, where we consider whether it is on xy or yz on zx plane. We can write this double integral over the S curl F bar dot n cap ds is equal to double integral R1 the region curl f bar dot n cap dx dy by mod n cap dot k cap. Okay, so here the second one, double integral over the s curl f bar dot n cap ds is equal to double integral over our region R2 curl f bar dot n cap dy dz by n cap dot I cap. And the third one, double integral over the s curl f bar dot n cap ds is equal to double integral over the region R3 curl f bar dot n cap dx dz by mod n cap dot j cap. Here you can see R1 is nothing but the, if you take the projection of the surface on xy plane, see here xy plane, okay, the R1 is the projection of the surface S on xy plane, and here R2 is the projection of surface S on yz plane. Okay, remember that R2 here the projection. If you consider the projection on yz plane, we'll try to consider the ds. We'll write this ds like this. If you consider the projection on xy plane, we'll consider the ds like this, dx dy by mod n cap dot k cap you will get. Xy k here you will get, and y, if you consider the projection on yz, you will get dy dz, ds can be written as dy dz by n cap dot I cap. Remember, okay? And if you consider the projection R3 here, the projection on xz plane. Okay, so there you can write that is the projection of S on xz plane. Then ds can be written as dx dz. The projection is on xz, dx dz by mod n cap dot j cap. So these are the important formulas we have in the Stokes theorem. Okay, so here this is the important formula that you must remember to understand this. Okay, I hope you understand. Thank you.